Welcome to solverfy.
This is the answer to chapter 27, problem number 8 from the Smith Organic Chemistry textbook. And this problem is very similar to chapter 27, problem number 6. In fact, the two molecules that we're asked to consider are the exact same molecules as we were asked to consider in problem number 6. However, in problem number 6, we were asked to determine what the products would be and their stereochemistry when heat was used to drive the reaction. And in this case, we are driving these paracyclic reactions with light. And so the rules for light are exactly the opposite of the rules for heat. So with heat, when we had an odd number of double bonds in a polyene, we would get disrotatory rotation. And for light, as I've written at the top here, an odd number of double bonds will give us conrotatory rotation. And likewise, with heat, an even number of double bonds gave us conrotatory. And in this instance, with light, an even number of double bonds will give us disrotatory rotation. And so the products are going to be very similar as they were for problem number 6. And so if we consider A first, we can see that we have 3 double bonds in this molecule. 3 is an odd number, obviously, so this is going to be conrotatory. So I'll just write con down there. So we can go ahead and draw our product. Once again, if it helps, we can draw the way that the electrons will move here. So that double bond will move, that double bond will move, and the electrons from that double bond will go to form the new single bond that closes this ring up. So we have the closed ring there. And now here's where the difference is going to come in. So for problem number 6, we got disrotatory rotation, and so both of our methyl groups ended up pointing up. However, in this instance, they're both going to rotate the same way, and since they're pointing different directions in our starting material, and they're rotating the same way, they're going to end up pointing different directions again in our product. And so there we go. That's what we see. And forgive me, I forgot these double bonds. So remember, there will be double bonds there. And then the other thing is, obviously, they could rotate the other way as well. So we will also get the enantiomer here, which I will go ahead and draw out. So everything about the molecule is exactly the same. The only difference is we could draw this methyl group away from us and this methyl group coming towards us. And so that's A. So for B, just like in 6, the starting material that we're given is not a polyene. However, the product will be, and the product will have an even number of bonds. And so we can say that this is disrotatory. So I'll write dis there. And then we can draw out the electron movement again, if that helps. So there and there, that single bond will break, and the double bond will move. And so our product, as we said, is going to have 2 double bonds. So there's backbone. There's one of our double bonds. There is our other double bond. And now we need to take into account the way that this molecule rotated. So it's going to be disrotatory. So our 2 methyl groups here are going to have rotated in different directions. So they could both rotate, if you want to think of it as sort of out. That would end up giving us this product. And then we could, and this product is going to be the EE product. So EE, these are both trans orientation around these double bonds. And they could also both rotate in which case we would get this. This is obviously going to be much more sterically hindered here, the ZZ product. So the EE product is going to be, oops. I was trying to draw a Z while I said E. So there's the ZZ product. So we're probably not really going to see this ZZ product because this EE product is much more sterically favorable. And so that's what we're likely to see. That's the answer for B. And that is the answer to chapter 27, problem number 8.